Hello, everyone. Thank you so much for coming. Of course, yesterday was Earth Day, or Monday was Earth Day, so there's no better time to pay attention to sustainable architectures. Cloud technology has enabled us to grow and scale our IT workloads. And with the rise of new intensive technologies, it is ever more imperative to evaluate the true cost of our architectures and ensure that sustainability is built into how we manage these. My name is Romy van Es. I'm a partner solution architect at AWS. And in today's session, we'll equip you with the background, frameworks, and tools to build sustainable architectures. We'll be joined by an exciting customer who will then show us how they have put into practice the best practices for sustainable architectures. So let's get started. Sustainability has always been involved in the way we design our systems, but the focus has slightly shifted over time. Today, we'll make sure that we'll cover the full picture of what it means to build sustainable architectures. We'll talk about the motivation of application teams to drive resource efficiency in the past. And then we'll cover what we are observing today when running sustainable workloads, as well as sustainable IT departments. And we'll top that off with what we are expecting to change in the future in order to be more successful in achieving our sustainability goals. The goal of today is to help you find the things to optimize in order to improve the sustainability of your solutions. So first, let's start by taking a look back. Optimization for resource efficiency is of course not new. I think it's safe to say that all of us celebrate the optimization of code. To shave off a few seconds of application response time, or in the deployment process, or when we're building the application. And a lot of these principles were focused on code tuning, as captured by books like these for Java. 400 pages of general applicable rules for performance management, creating a plan, and then a test, measure, and learn loop. Mainly, they were very specific to the implementation. Should I use an array over a linked list? Should I use a vector? And how do I use with strings? How do I work with strings? Rather than the overall architecture changes of the full stack. Mainly, and of course, as this was the pre-cloud era, it was all driven by the fact that we had to work within the static boundary of the infrastructure we had available. And of course, the financial budget that was associated to that. To get more hardware was often a complicated, unknown process governed by someone outside of our team. Much less work it was to tune our code. Now, the definition of an infrastructure boundary, of course, changed around 2006, when AWS announced Amazon EC2, Elastic Cloud Compute. If we look at the announcement blog here by Jeff Barr, who was apparently also a visionary when it comes to remote working, EC2 was a clear response to the issues of that static infrastructure boundary. Customers scale it up as they need it for peak use, and then scale it down when not needed. Using the economies of scale, EC2 has always been an efficient, multi-tenant infrastructure compared to the single-tenant equivalent in on-premise data centers. And this completely changed the attitude towards optimizing for efficiency, leading to a little bit of a rebound effect for sustainable architectures. Especially since EC2 was so efficient in operations, we now had a choice. Either we read that book, these 400 pages, and we make an often risky code change, maybe introduce some regression, or we just spin up more of that efficient elastic infrastructure, give it more CPUs, add more of those boxes in a horizontal cluster, often with little more marginal economic cost. The choice was often obvious. I'm not saying you should never use more resource, but the key is that we do it as long as our business needs it. Growth in resource should be aligned to the demand of our customers or to the growth of our business. And this really puts architecture optimization in the context of economic cost rather than environmental cost. But it did start to integrate frugality in the way we build architectures, and not just code. More than a decade ago, Werner Vogels, the CTO of Amazon, already started to advocate for such cost-aware architectures, where we track and model not just cost, but cost efficiency. It was a call to use the elasticity of the cloud, and as we grow our infrastructure, to utilize the economy of scale to increase efficiency. And it was in the same year that AWS announced the AWS Well-Architected Framework to provide plenty of design principles to implement these cost and performance non-functional requirements and tune our applications to achieve that cost efficiency. Now, in parallel to technology teams figuring out the impact and the economic cost of our decisions, awareness around the environmental cost of human action was growing around other stakeholders in the organization. Sustainability became a key requirement to make decisions, whether that's who to buy from, who to work for, and who to invest in. And this has led to organizations adopting sustainability goals in order to answer to this demand. Companies communicate their goals in public pledges, like the climate pledge in our case. Amazon was one of its founding members, but today it has over 400 signatories across the world. The goals in the climate pledge include to be net zero carbon by 2040, which is 10 years ahead of the Paris Agreement. And this has made sustainability a driver or a requirement for all parts of a business's organization. Now, the aligned focus of decarbonization that comes with these pledges led to the Greenhouse Gas Protocol, or GHG, becoming the most well-known framework to quantify and monitor emissions. So let's have a look at its main concepts, as this will inform the way we look at sustainable architectures. You may have already heard of the protocols Scope 1, Scope 2, and Scope 3. Scope 1 covers direct emissions. Burning fuel, wood, anything that burns or emits greenhouse gas emissions. Those emissions contribute to the direct, as part of the direct operations, contribute to Scope 1. Scope 2 are direct emissions coming from purchased energy. This can be the electricity in the grid, for example. Its carbon contributes to Scope 2. And then the often infamous Scope 3 covers rather indirect emissions. These can come from upstream and downstream activities of a business within the supply chain. Scope 3 depends on your production depth, the goods and services you provide, but also how you deliver and dispose these after use. In IT, that is equipment that is built and delivered to our facilities, such as the racks and servers. But it could also be the building, for example. And as this includes all the activities in our supply chain that are indirect, it also partially means that the emissions coming from our suppliers and consumers are included. All of the carbon emitted there will contribute to Scope 3, which shows how complicated this calculation is. Now, altogether, the three scopes provide a complete picture of an organization's emissions. And the framework can and then should attribute emissions to each team across the three scopes, giving everyone ownership of their part of the emissions. This applies to a shop floor in the case of manufacturing, but it also applies to a single IT application. And this is how sustainability has now ended up on the desks of IT teams like ourselves. In this way, there is a shift from solely economic cost to environmental cost, or rather sustainability, to become a key driver for us all to drive optimizations in their applications and in our architectures. I personally have met some application teams who put resource efficiency and cost of their architectures as a relatively low priority, as long as they could reach other non-functional requirements like availability and performance. Now, with the raised attention to sustainability and the company-wide pledges, we all are faced with new pressures from our customers, investors, as well as our partners and employees to make sustainability a proper non-functional requirement. And so here we are. So let's move to what we are seeing today to address this. We'll cover some of the processes, tools, and cultural principles that customers and you and I can use ourselves. Now, of course, when we talk about improving architectures, one thing comes straight to mind, which is, of course, the AWS Well-Architected Framework. It was launched 10 years ago originally, but 2 years ago we added the sustainability as a dedicated sixth pillar to the framework. The framework as a whole provides a tool, a set of white papers containing best practices and design principles across the 6 pillars of security, operational excellence, reliability, performance, cost optimization, and now sustainability. The framework works as a consistent approach for customers and partners to evaluate their workloads in the cloud and effectively balance all the 6 workload requirements. Now today we'll of course zoom in on the sustainability pillar. Here you can see the structure. Now many often come for the best practices on the right, but we also want to draw attention to other pieces of the pillar, like the trade-offs, the KPIs and proxy metrics, and whose responsibility it really is when it comes to sustainability and the cloud. At the foundation of the design principles lies the shared responsibility model, for sustainability in this case. So much like with security, both AWS and you ourselves take ownership of the sustainability of a workload. As part of these commitments and the pledges that we have, AWS designs the buildings, rooms, servers, and takes care of these from construction to recycling. AWS also purchases the energy and ensures that other resources, such as water for cooling, are used in an efficient way and sustainably. And lastly, AWS service teams design and run the services and optimize these for sustainability, taking that into account. Yet it is your responsibility as users to make sustainable architectural decisions, to select and use services sustainably, and determine which code or which resources are running and how this is done. This has an impact on region selection, as well as the way you use data and the culture you put in place to keep this operational. Now we can bring these 2 responsibilities, these activities together, and picture that in this simple model on the screen. It shows how these responsibilities effectively feed into each other. In the end, service usage by the customer and the sustainability of these services as delivered by AWS make an impact, or rather, produce an output. The amount of services used by you as the customer is then the input metric to that output. So we use these 2 concepts as we further elaborate on how we can manage this. So let's double click on each of these. Some of the outputs are driven by variables within the AWS services. Now, a very well-known output, of course, is cost. Right? Cost is driven by the variable that is pricing terms of the services, which of course are different for each service. But now we have a new output, the emissions. And we saw that this is a more complicated calculation as per the GHG protocol. It requires insights in the variables like energy as well as the physical resources involved to running a service. Now, to give you the ability to manage this output of emissions effectively, we have launched the AWS Customer Carbon Footprint tool, and this tool provides you the data of the output metrics of Scope 1 and Scope 2 of the GHG protocol, and associated to all your AWS users in this case. You can see this on a payer level or individual account level, and the data is broken down into 3 service categories and 3 geographies. You can then download a CSV file in order to analyze that data in other tools. The data is reported at monthly granularity, 3 years back in time. And you can forecast changes as Amazon stays on the path to 100% renewable energy by 2025. And now to gather and process all the necessary data for accurate reporting, the tool has a lag of 3 months to provide a month's worth of data. Now, in order to optimize for these outputs, or often reduce them, we have the responsibility to tweak the input metrics, or rather the things that really drive that usage. Take the cost and usage report to understand your AWS service usage, but you should also walk upstream into the chain to understand the operational processes and the real business needs that drive the use of those services. The earlier in the chain we can understand that or build insights into that, the better our optimization cycles will be. Yeah, here we go. Now, the input and outputs we can then bring together to create more fine-grained and timely metrics that better reflect the impact of our service usage near real time. These we call proxy metrics. To give you an example, rather than counting the amount of M5 instances, the emissions coming from an application are better reflected if we take into account how long that instance is running. The proxy metric for this would rather be vCPU hours than a number of M5 instances. Now, where the proxy metrics give us better reflection of the impact of part of our applications, they are still not quite giving us full context of how that relates to our business drivers. An increase in resource usage is not really an alarm or cause for alarm if our business grows, but a steady drop in customer demand as our resources are being used more would be. For this, we want to use business metrics which reflect the health and growth of our business. And they are specific to each workload. Now, examples of business metrics could be active monthly users, transactions to the platform, or content impressions. Bringing these business metrics then together with the normalized proxy metrics, we can build a sustainability key performance indicator of our workload. The KPI is a direct metric that allows us to track resource usage or environmental impact in direct relation to our business need. It's much like building a cost-aware architecture, but in this case, we're building a sustainability-aware architecture. Now, optimizing for these metrics always needs a change. And sometimes you can do that without affecting the user experience or our service level agreements. So if we want to work with these KPIs, these sustainability KPIs, we must know the boundaries in which we can move it, as well as if we can move it at all. In other words, we must know how we're performing against our SLAs. And if we're overperforming, perhaps we have opportunity for research reduction. So an example would be, we can reduce the I/O by approximating results in case we are overperforming. We can reduce the compute resource if we can afford higher response time as per our SLA. Or reduce idle online capacity if your availability requirements can be relaxed. So that provides us the full context of where we can implement optimizations. Now, in order for you to get started with this approach of proxy metrics and sustainability KPIs, you can use our Cloud Intelligence dashboard for proxy metrics. It's an open source code to set up everything from queries to the cost and usage report, as well as an Amazon QuickSize dashboard that shows the normalized data by account or tag. You can then even ingest your business metrics to build your own sustainability KPIs. Now, you can access it here as well as a demo, but let's give an example of the dashboard. You can see the example here, specifically showing the compute tab. If we look at what we are seeing, you can actually already spot some rooms for improvement in this case. In the top graph, we can see for the color blue of AWS Fargate, as well as hardly any purple for AWS Lambda, which shows a potential improvement through the use of more serverless technology. Then in the graph below, we see that early generation instance types are still very much in service, where there might be more efficient and performant instance types available. We see that it's mostly x86-based instances, and no ARM64-based instances. In other parts of the dashboard, you can also see the activity across the regions. And this allows you to optimize your region selection to use one of the 19 regions that today are already operated by 100% renewable energy. So this is a good example of how you can work with dashboards to see and optimize or identify optimizations. But which optimizations then to implement, of course, are given in the design principles of the well-architected pillar. They are given as a set of questions that you can use as a checklist to review your workload. And they come with a short description, anti-patterns, as well as links to implementation guidance. The pillar comes with a group of 6 topics, which are region selection, alignment to demand, software and architecture, as well as data patterns, and hardware and services, and then as last, process and culture. Now, rather than showing you all these best practices myself, what's better than having someone show us how it worked for them? To do that, we have Government Digital Services join us today, and they will walk us how they have implemented these best practices for one of their key workloads, OneLogin. So with that, let me welcome to the stage Jennifer Marks, who is the Head of Digital Sustainability at Government Digital Service.
Thanks, Romy. Good afternoon. I'm Jennifer Marks, the Head of Digital Sustainability at the Government Digital Service, GDS. The government's net zero strategy is the drive to be net zero and to decarbonise all sectors by 2050. But what does sustainability mean for technology? At GDS, we're in the process of developing and delivering gov.uk OneLogin, the single sign-on service for all government digital services. If you logged on to pay your taxes, or if you've had to sign your mortgage deed, then you may have gone through OneLogin to identify yourself. At OneLogin, our director had a vision to make it the greenest digital service across government. And this is where our story begins. The technology we use today comes at a cost to our planet. By 2025, it is estimated that the total volume of worldwide data will exceed 175 zettabytes. 1 zettabyte is equal to 1 trillion gigabytes. The greatest threat to our planet is the belief that someone else will save it. This afternoon, I will speak about the sustainability journey that we in GDS are on, about the methodology we developed to measure the emissions of OneLogin, and about some of the AWS tools and best practices that Romy spoke about, and also how the culture is changing towards digital sustainability across government. Following a huge amount of research into digital sustainability and understanding what already existed and what was wickedly complex, we developed our ambition. We want to support teams across government to successfully embed sustainability into their digital services. Sounds pretty simple, right? But those words are the simplest thing about it. Because our ambition is not about the greening with IT, it's about the greening of IT. The first thing we needed to do was to create a baseline. We needed to understand and quantify not just the energy OneLogin used, but also understand the resources being used to manage and develop this service. So after researching lots of other methodologies, we developed our own methodology, and we used it to measure the emissions of OneLogin and later gov.uk. We had a baseline, 193 tonnes of CO2. Great! But what next? How do we make that figure meaningful or indeed useful? For OneLogin, we put in place a dashboard to monitor the emissions, and we used the AWS Proxy Metrics dashboard, which Romy spoke about. A really important thing in setting up the dashboard was actually to define the business metric. Without a well-defined business metric, the dashboard would not have been able to deliver the insights or indeed the understanding needed to make effective changes. So what are the inputs that were used for OneLogin? Well, if OneLogin manufactured pens, it would have been pens. But because OneLogin's in the business of identities, we identified 3 necessary inputs: people logging in, people identifying themselves, and people creating accounts. And once defined, we were able to calculate the carbon cost per identity. And from there, we started to develop an improvement plan and identify interventions to drive it down. But being government, we had to strike a fine balance. A balance between being as environmentally sensitive as possible, whilst also being citizen responsive. As Romy said, the sixth pillar of the AWS Well-Architected Framework is sustainability. And in using the guidance and the design principles, we aligned OneLogin to it, and of course we started to apply the best practices. This afternoon, I'm only going to focus on the ones that have influenced our choices and where we have implemented changes. Hardware and managed services, software and architecture, and alignment to demand. Hardware. OneLogin has a serverless architecture, and as far as I'm aware, is the only major digital transformation program across government to go entirely serverless. Now, being serverless, there aren't that many options available, but we chose to look at processor architecture. A study in Japan by Telco found that by changing one line in our code, we could expect an average 72% reduction in power consumption with our processors. With one line change, such a simple win. So we did it, and the benefit was immediate. We take advantage of the serverless pattern wherever we can, and this includes managed services. Our web front end is a Node Express application, and we run this on containers. But we don't want to have to think about the servers, so we use AWS Fargate. We've designed our system so we don't need a relational database. We use DynamoDB instead. We have decoupled our functions by architecting for an event-driven architecture, and we use SQS as our message broker. And because most of our user journeys can be mapped using graph theory, we can use step function state machines. It's easier for the developers to reason about, but it also reduces the code footprint of our Lambda functions because we don't need to include the AWS SDK. We don't need a file system. We use S3 for long-term object storage. And pretty much all of this scales in and out without us having to think about it. But let's look at alignment to a demand. There we go. This dashboard is typical of our usual weekly traffic. People want to conduct their business with government during the day, a little bit at weekend, but almost never overnight. So it should be easy for us to scale up and down according to this traffic pattern. Nope, you'd be wrong. Because we frequently experience unexpected surges of traffic through what we have coined the Martin Lewis effect. On what should be a boring and predictable evening, Martin Lewis, the money-saving expert, goes on primetime television, and he tells the millions of people watching that they can save money by applying for something on gov.uk. And at that moment, the surge begins. Now, to run hot all the time would not be practical or indeed sustainable at any level. So we looked at step scaling to avoid turning up the heat constantly. Step scaling gives us assurance that the system can cope with these traffic surges without having to be wasteful around the approach. In the same vein, we fine-tune our Lambda functions, because what matters is memory and runtime. The sweet spot in the graph is 1,024 megabytes. It doesn't go any faster if we double it. It's both incredibly wasteful and exceptionally costly. And at 150 milliseconds faster than at 512 megabytes, for no extra cost, saves a huge amount of processing time as it is executed millions of times a day. This is where we can be stewards of the energy available by releasing resources to be used elsewhere when we finish with them. From the start, in developing OneLogin, we have ensured a green approach. But this is only the beginning of our journey. We will continue to iterate, to develop, to improve as we learn more. We have successfully measured the emissions of OneLogin, but also of gov.uk itself. And over the course of this year, we will finish measuring the emissions of the other GDS services. We are supporting this work by the development of measurement dashboards to monitor the emissions, and we're a recipe card listing out the improvements that can be made to a system. But it is not only in GDS where momentum around digital sustainability is growing. We are working with cross-government colleagues to collaborate on pathways and deepen our understanding of digital sustainability, what it means, what we can do, how we can lead, and what's next. The Government Digital Sustainability Alliance is a public-private sector alliance led by DEFRA. It brings together representatives from across government, IT suppliers, academics, NGOs to talk about the planetary missions of digital services, Scope 3 reporting, the circular economy model, and much, much more. It's vital that suppliers continue to work with the government on progressing and promoting the knowledge of sustainability in the technology and digital sectors. Because the technology we use today comes at a cost to our planet. Can everyone hear me now? Sorry about that. Sustainability can no longer be seen as the poorer sibling to other requirements for digital projects. It has to be an embedded requirement, and there's good reasons to believe that we can change that. Everyone in this room has the skills and potential to make a difference. Sustainability is everyone's responsibility. We urgently need to change and rethink our approach to planet security. So I urge you now, each and every one of you, to be brilliant. We have run out of time to be anything else. Thank you so much for listening, and I will now pass you back to Romy to talk about the future of digital sustainability. Thank you.
Very well. Can we hear my mic, or do I have to be here? It works fine? Very good. Thank you, Jennifer. That was truly inspiring. So let's move on to see what the future looks like for sustainable architectures. The upcoming decades will be critical in achieving our sustainability goals, and we need to build on the efforts of the past and the present to accelerate. Innovation is the key to making this happen, so let's look at what you can do, as well as where AWS continues to innovate. Now, both you and AWS contribute significantly and independently to sustainable architectures, each in their scope of influence as per the shared responsibility model. Now, let's zoom in on the AWS part of the story. AWS is continuing to innovate for resource efficiency within our data centers, hardwares, and servers, for which I want to highlight two particular topics. For the first topic, the future is actually very close. Amazon is on a path to power all operations with 100% renewable energy by 2025, of which we actually already achieved 90% in 2022. We are continuing to build investments in regions where the grid is still highly dependent on fossil fuels, and we've added new projects in 2023 with over 30 new projects across the Asia Pacific, such as South Korea, India, and China. We also announced the build of the first solar farm built on a brownfield, which is land that has been abandoned due to industrial pollution. So clearly, we're using land where we can. For the second point, we must realize that sustainability is not just about decarbonization, but also looks at other resources like water. At reInvent 2022, we announced we will be water positive by 2030, which means that we'll return more water to communities than we use in our direct operations. Ever since we've announced that, we have already improved our water efficiency metric from 0.25 to 0.19 liters per kilowatt hour. The key to this is to increase the use of sustainable water sources like recycled water, reusing water for cooling, but also to increase water availability in communities around the world. And for this, we have announced 6 new replenishment projects across Australia, Indonesia, Spain, and the United States. The progress we make on these commitments will drive the resource efficiency of our data centers and our services. But we can take on much more of that responsibility when we can closely align to the requirements of your workloads. By identifying your constraints, or rather where these constraints can be relaxed, we can then enable trade-offs between efficiency and service optimization, like we saw earlier. We can then build the right services that allows us to align to this exact demands, and in order to take on more of that responsibility around sustainability. It is our goal to take over as much responsibility there, such that you can focus on your business differentiators. Now, a key example of where we've done that in the past is that there's a lot of choices for serverless technology across the services. For example, now we have serverless choices for databases, caches, and data warehouses to reduce the overall overhead for managing the peaks. Now, two other examples of such signals being provided to us are for compute. With Glue Flex execution classes, you can build in flexibility around varying priority and time sensitivity for your ETL workloads, which translates to using spare compute capacity instead of dedicated hardware for your ETL jobs. Similarly, you can signal flexibility in compute capacity with EC2 M7i Flex instances. Service choices like this allow us to make decisions that allow for less energy and less resource usage. In storage, you can also signal flexibility, and then we make trade-offs for efficiency in terms of hardware and availability. So as an example, let's look at Amazon S3 Glacier Instant Retrieval. When we look at storage, hard drives remain the best way to store large amounts of data when we need to be able to access it immediately. But while over the last decade storage density has increased, IOPS didn't. This means that on a per terabyte basis, hard drives are actually slowing down. And you won't be able to scale the demands of a single storage tier this way. Either we will have very full but very idle hard drives, or very active drives which are underutilized. So this is an example where we have then shared that disk with S3 Glacier Instant Retrieval with the less frequent access version. With these signals of storage demands, we can use that resource efficiently, and we can also pass on the savings to our customers. The future will be full of such optimizations that are driven by sustainability and frugality. Now, if we look forward in the past and present, we have established baselines, defined how we measure impact. Now the goal will be to monitor and automate this as much as possible. The well-architected pillar already gave us some prescriptive tooling that continuously analyzes our workloads for optimization opportunities. Now, checking for some typical improvements, we can also use Amazon Code Guru Profiler to identify expensive lines of code. We can use Amazon S3 Storage Lens to identify barely accessed objects and cold buckets. And AWS Compute Optimizer checks for underutilized EC2 instances, EBS volumes, and where better AWS Lambda configurations exist. And of course, we also saw the Cloud Intelligence Dashboard that gives us actionable insights and opportunities for optimization. Now, another great tool that I want to show you today is the Sustainability Scanner, which is an open source tool that checks your cloud formation templates against the AWS Well-Architected best practices. It does that at the build time, so before deployment to production, and it provides a customizable set of rules. The script is called in the cloud formation template itself, and then generates a report with optimization opportunities and a sustainability score. You can access the repo here, but you can also include it as a GitHub action within the workflow. Now, we saw some tools, and in the future we'll have many more of those tools that help us drive visibility and automation of our needs when it comes to sustainability. To recap on the tools we saw today and give you a bit of a structure on how to use these, if you want to report on the carbon emissions of your AWS resources and observe actual historical progress and forecast, you use the AWS Customer Carbon Footprint tool. If instead you want to quantify input metrics for improvements and make use of showback mechanisms, you use the Sustainability Proxy Metrics and KPIs. With these, you can then observe the changes and find the hotspots. And finally, to get recommendations specific to your workload, you can use the readily available tooling that we just saw on the screen, as well as a sustainability scanner. Because of course, as I'm sure you've heard during this summit, the future also holds new emerging technologies that are expected to change the way in which we build solutions. And these technologies are more resource intensive than ever. It is therefore critical that we learn and start to build out such workloads, not with the mindset from 2006, but with the mindset from 2024. As we think about sustainability and we start experimenting, we can then realize that we can use existing models and that they will actually achieve good enough results for our use cases. We need to make these decisions close to the needs of our use case, and that means that fine-tuning might achieve better results than prompt engineering, but sometimes might use too many resources for our needs. The basic baseline is no matter what workload, use the AWS best practices to implement that from the start and not as an afterthought. And in particular for generative AI, we have launched a blog that gives best practices for these types of workloads, which you can find on the AWS blog channel. And in this way, the sustainable behavior of the IT department can become a real jumping board for sustainability through the rest of the organization. And for this, it is critical that we build sustainability not just in our architectures, but into our culture as IT teams. To do this, we need to build ownership and accountability into the way the Cloud Center of Excellence operates. In this way, IT team members, you and I, can become advocates for sustainability and to build new workloads that are focused on the priorities across the business, as well as drive the innovation of new digital sustainability-first experiences. Because that's where the real future lies. As we saw in the GHG protocol, every team needs to be involved in achieving sustainability goals, and digital solutions can provide the gateway to making this happen. So as we mature the sustainability of our infrastructure and architectures, think about what emissions need to be resolved across the wider organization and how we can use those 200+ services to solve wider industry challenges. Use cases can include carbon accounting, energy optimization, sustainable buildings, and many of these we provide prescriptive guidance on in the AWS Solution Library. So make sure to check these out. Doing this is when we shift from a bolt-on, less harm, must-do approach to sustainability to a more built-in, proactive, do-good mindset. And that's where the future needs to be, for both IT as well as the wider business. So let's recap on the main takeaways from today's session. First, start by tracking and visualizing your progress. Establish showback mechanisms for application teams based on the carbon footprint tool, as well as proxy metrics. Then start with directionally correct optimization opportunities and use the recommendation tooling where we have shown that. Focus then on the biggest opportunity of change. And finally, use technology and data to solve sustainability challenges through the cloud and not only optimize for IT. As the world of technology takes us on an exciting journey of seemingly endless possibility, it is important to keep in mind that technology serves people and planet, and not the other way around. We dictate how technology is used, and gaining insights into the sustainability of our workloads is the critical step in making sure that these decisions serve people and planet. Thank you for spending the time with me today, and thank you for Jennifer for joining me. Enjoy the rest of your summit, and please take some time to fill out the session survey to let us know what you think. Thank you.